All right, so today we're going to take a look at lesson 11, which is creating equations and inequalities in one variable. So to start off, we're going to take a look at some definitions to review. The first one here says an algebraic expression is a mathematical statement made up of numbers, variables, and operations. So when we're talking about algebraic expression, it's just any combination of numbers, variables, and operations. So notice there's no equal sign here, but an expression is just made up of numbers, variables, and different operations. So for an example, one example of an expression might be 2x plus 3y plus 49, right? So here we have variables, numbers, and then we have variables with coefficients in front. Notice how we don't have an equal sign, right? Algebraic expressions, no equal signs. Next thing says, expressions contain terms, factors, variables, and coefficients. So the first word here, a term. A term is a part of an expression that is separated by addition or subtraction. So when we look at our example that we had here, each of these is a term. And term. Because it is part of an expression, right? So you have a coefficient and variable, and it's separated by addition or subtraction. Next, it says a factor evenly divides into a polynomial. So that's a good one. A factor is something that evenly divides into a polynomial. A variable, right, is a quantity that can change or take on different values. So variables are the numbers that we don't know, right, that we have to solve for. Then finally, a coefficient is just a number that multiplies a variable or power of a variable in a term. So remember, our coefficient is just our number in front of our variable. So in this case here, if we take this first term here, 2x, right, it is made up of a variable, which is x, and a coefficient, which is 2. And this 2 is multiplied by x there, but we just write it as 2x. So the coefficient is 2, variable is x. Next, it says a polynomial is an algebraic expression of one or more like terms. So polynomial expression, one or more terms. One example here is 8y. Another example is 8y minus 1. Another example is 8y squared minus 2y plus 4. Those are all examples of polynomials, right? This example that I had written earlier, 2x plus 3y plus 49, is also an example of a polynomial, right? Poly means many, so it's made up of many terms. The degree of a polynomial, is the highest degree of any term in the polynomial. And when we're talking about the degree, right, we're talking about the exponents of each variable part of the term. So the exponents of each variable part of the term. So if we're taking a look here at this sample question. We have a polynomial. It has four terms, 5x cubed plus 2x minus 3x squared, or 3x to the 6th power plus 9. If we wanted to know the degree of this polynomial, we look at the term with the highest exponent. So the term with the highest exponent is 3x to the 6th power. So our degree here is equal to 6. We take the highest exponent. And if we're looking at our choices here, this polynomial does not have 3 terms, right? We said it has 1, 2, 3, 4 terms, which is choice B. The polynomial is not to the degree 3 because our highest exponent is 6. It's also not to the degree 4 because our highest exponent is 6, which leaves us with our correct answer of B. Taking a look at the next part here. So now we're moving on from expressions and taking a look at equations. So an equation is a mathematical sentence showing two expressions equal. So an equation shows that two expressions are equal. So that's when we see our equal signs here. A linear equation is an equation in which equivalent expressions has a degree no greater than 1. So if we have an expression with terms that are no greater than 1, have a degree no greater than 1, it is a linear equation. An inequality, right, which is what we've looked at a couple times already, is a mathematical sentence comparing two expressions using these symbols: less than, greater than, less than or equal to, or greater than or equal to. Equations and inequalities can be used to solve real-life situations. To solve these problems, start by setting up an equation or inequality, choose a variable to represent the unknown quantity, and then use what you know from the given information to write an equation or inequality that can be solved for the variable or the value of the variable. So what we're going to be doing today is setting up different equations and inequalities, right? Then solving those inequalities to find the variable of something that we're trying to, the unknown value we're looking for in each problem. So if you take a look on page 74-5, start by looking at the top here. So we have sample question number 2. It says, 3 friends share the cost of a pizza. So that's the first piece of information we have here. So we have 3 friends sharing the cost of a pizza. The base price of the pizza is the variable P. And the extra toppings cost $4.50. If each person's share is $7.15, which equation could be used to find P, the base price of the pizza? So if you take a look at all of the examples they have there, all of our choices, none of them are actually solved for P. So here they have all of these equations solved for how much each person's share is. So if we start off with how much each person paid, which is $7.15, and set this equal, if we wanted to find how much each person paid, we would have to take the total cost of the pizza, which is the base price plus $4.50, and then divide it by 3. So if we take the total cost of the pizza, right, parentheses, which is the base price plus $4.50, and we divide that by 3, we would get our $7.15. So then you're just looking which one of these answers looks similar to here. So if I'm dividing by 3, we can also rewrite this as saying we're multiplying by 1/3. So if I write $7.15, instead of divide by 3, I can multiply by 1/3 P plus 450. And this expression, if we look at our answers, is choice D. So looking at the other answers and why they're not correct here, choice A is saying that we multiply the base price of this one pizza by 3 and then subtract the cost of the toppings, and that's how much each person pays. That doesn't make a whole lot of sense. Question B is similar to ours, where it takes 1/3 of the base price of the pizza and splits it between 3 people, which makes sense, but then it does not split up our toppings 3 ways. So that's not the answer. And then finally, choice C would not be correct because we would not multiply the base price plus the toppings times 3 to get one person's share, right? That would be if we wanted to get maybe the cost of 3 pizzas, which leaves us with choice D, which is where we take 1/3 of the total cost of pizza, and that's equal to one person's share. Let's take a look at sample question number 3. So sample 3 says that Leah estimates that she owes $3,455 in taxes. So this is how much she thinks she owes. She uses the equation below to determine the estimated taxes she owes based on D, which is the total dollar amount she earned in the past year. So this is her equation, and it wants us to find the value of D. So for this problem here, we're just going through and solving the equation. So if we start with 3,455 is equal to 0.15 times d minus 7,550 plus 755. The first thing we need to do is remove the parentheses in this equation here. And we're going to do that by using the distributive property. So make sure you have a calculator handy here. We're going to start by just bringing down our line, two sides of our equation, rewrite our 3,455. Then we're going to distribute our 0.15 to both d and to negative 7,550. So 0.15 times d is equal to 0.15 d. Then 0.15 times minus 7,550 is equal to minus 1,132.50 plus 755. Then we can collect our like terms on our right side, so we can add negative 1,132.50 plus 755. And first we'll bring down our left side. We still have our 0.15d. And then if we have minus 132.5 plus 755, we'll get that that is equal to minus 377.5. Now we want to get d by itself, so we'll add 377.5 to both sides. When we add 377.5 plus 3,455, we get that that is 3,832.5, and that's equal to 0.15d. Now to get d by itself, we divide both sides by 0.15, divide by 0.15, and we get that d, right, the total dollar amount that she earns, is $25,550. So $25,550, we look for that choice here, and $25,550 is choice C, which is the total amount of money that she earned that past year, and using this equation here. So this was just a real-world equation, and it was solving an equation. So something we've done many times, but in a real-world circumstances here. The next one here says that Ellis can spend up to $40 for gasoline and a car wash at a service station. The car wash will cost $6 and the gasoline will cost $4.50 per gallon. The inequality below can be solved for G, the number of gallons of gasoline that Ellis can buy. Which statement is true? So again, this one here, we're just going to go through, solve our inequality using the same rules that we would for an equation, and then compare that to our answers to see which statement is true. So we start with 4.5 G plus 6 is less than or equal to 40. So our first step here is to subtract 6 from both sides. So over here, these will cancel out, and we'll have 4.5 G is less than or equal to 40 minus 6 is 34. Then we go through. We want to get G by itself, so we divide both sides by 4.5, divide by 4.5, and 34 divided by 4.5 gets us that G is less than or equal to 7.555, right? It looks like this is going to keep going here, but our calculator rounds it up. They're at 6 here. So now let's see here. So the amount of gallons can be less than or equal to 7.555 here. So when we're going through here, let's see which one of these is true. So Ellis can buy over 10 gallons of gasoline. No, because Ellis can only buy up to 7.555. Ellis can buy at most 7 gallons of gasoline. That's not true either, right? Because Ellis, you can buy more than 7 gallons. Ellis can buy up to 7.55 gallons. And when you're pumping gas, right, you don't have to stop right at the gallons. You can get to certain fractions of a gallon as well. So C says Ellis can buy 6 gallons of gas, but not 7 gallons of gas. That's not true because Ellis can buy both 6 and 7 gallons of gas. And the last one, Ellis can buy 7 gallons of gas, but not 8 gallons of gas. That's going to be correct here because Ellis can buy 7 and all the way up to 7.555, but not quite 8. So if we take a look, choice D is our correct answer. Ellis can't quite buy 8 gallons of gas, so that one's correct. All right, so now I'm just going to go through the questions in the problem set, all right, and just review kind of how to go about each one here. So the first one here says that Kathy is placing 3 ring binders on the display shelf. Each binder is 2.5 inches wide and the shelf is 48 inches wide. When we see the words each, or if we see the word per, we're thinking about multiplying. And then this is also going to indicate that our variable, right, is the number of binders. So how long a binder is what we're multiplying by, which will eliminate 2 of your choices, C and D, because you want to have the coefficient 2.5 with the variable that we're multiplying by. The next one here says, the amount a library charges each day a book is late is 25 cents. Caden wants to write an expression to represent the total cost of a book that is days late to the library. Which statement is true if the coefficient of the expression that represents the situation? So again, the coefficient is how much something happens per day or each day. So here they're giving you that each day, right? It's 25 cents for being late. So if you're doing something with a coefficient, you're going to have 25 cents multiplied by something, right, in this expression there in order to find the amount of the charge late. So looking for the one that has to do with that. Choice C and D. D is the coefficient. So let's remember, coefficient is the number in front of a variable. D is a variable, so it cannot be a coefficient there. All right, moving on to question 3. So question 3 says that a warehouse elevator can hold at most 1,750 pounds. A 200-pound worker loads the elevator with boxes that weigh 75 pounds each. So again, we see 75 pounds each. So the inequality, see where 75 multiplied by the amount of pounds plus 200 is less than or equal to 1,750. Describe the maximum number of boxes the worker can put in the elevator. So which statement is true? So this goes back to the same example, sample 4, right? You've got an inequality there, right here. 75b plus 200 is less than or equal to 1,750. You need to solve that inequality using the steps that we know how to solve an inequality, and then make sense of which one of these statements is true. So remembering that this is a less than or equal to sign, right? So when we're talking about less than or equal to, that would be at most, the word at most. So you'll be able to make sense of which one, choice A, B, C, or D, you would choose for that one after you solve it. The next one here says the width of a rectangle garden is W feet, and the length of the garden is 4 feet longer than its width. The entire garden is surrounded by a walkway that is 2 feet on each side. Which statement is true? So for this one, I'd go through, draw a picture. All right. So we have the width, which is W. We have the width plus 4 for the length. But then on top of that, right, we have a pathway that goes around, which is plus 2. So if we're looking at this distance here, oh, sorry. So we have, again, our width plus 4, right? Then we have a pathway going around it, and each of these is going to be plus 2 going out this way, right? It goes plus 2 going up that way, plus 2, plus 2, plus 2, plus 2, plus 2, plus 2. So think about which one of these statements would be true for a diagram that looks similar to this here, where we have our length is the width plus 4. The width is the W here. But when we're talking about the total length or total width, we have to include the walkway. All right, question 5. Question 5 says that Trish started out with 40,000 miles on her car and drove exactly 800 miles a week. So started with 40,000 and drove 800 miles a week. After how many weeks did she have 44,800 miles? When we see this 800 miles a week here, right, we're looking for weeks. So our variable should be W for weeks. And then when we see 800 miles a week, this is also like per week or each week. So think about what you have to do with that 800. And then you can write an equation here. And then part B just says to solve your equation for the number of weeks. Then the last question here has to do with the perimeter of a rectangle. So it must be no more than 500 feet. The width of the field is 90 feet. Write an inequality to find the possible lengths in feet of the field. So real quick, I'll kind of get you started a little bit here. If we have the perimeter of an object, right? So the perimeter, if we were saying perimeter, it's equal to 2 times length plus 2 times width. So in this case here, we're talking about the perimeter can be no more than 500 feet. So it has to be less than or equal to 500. So if we were to write that 2L plus 2W, it has to be less than or equal to 500. Then you can go through here, substitute in what you know from the equation up here, right? And then you can find our possible lengths here. So you can create an inequality and then find the possible lengths. So that's part A and part B. Again, hoping that these videos are reaching you and they're helping you out get through some of this here. If you have any questions, make sure to message us on Schoology or through Google Voice or through email or through any way possible. And we'll get back to you and be able to help you out with any questions you do have going through these lessons here.